Back to another video, guys. You're on the Circle Theorems problems. That's all about GCSE and iGCSE revision. That's medium level. Make sure you remember how to work with the basics for circles. Here are two problems that you're gonna go through. That's the first one. You need to pause the video, try to do very wrong, and then let's compare it with my explanation. Okay, so what do you have? You have the circle, you have the tangent, and you need to figure out the degree measure of the angle MCA. Okay, so how to work it out? Simply, I'm going to use the theorem about the circles that any radius perpendicular to the tangent, which it shares with the tangent line. Okay, in this case, radius is the segment OC, and ML is going to be the tangent line at the point C. So what it means the angle that formed between those two segments is 90 degrees. So from the left side, if you have a look at the angle MCO, so angle MCO is going to be obviously 90 degrees as well, okay? And it consists of the angle 40 degrees and our target angle, which I mark as x degrees. So this is an angle MCA, so I mark as x degrees. So from there, you can figure out easily that the measure of this angle is 50 degrees. Okay, so we worked out that this angle is 50 degrees, and we can go to B part. If the arc length of minor arc AC, so I just put the dashed lines along the minor arc, it's right there, okay? So up to C. The measure, the measure of this arc is 10 pi centimeters. Okay, you need to figure out the radius. So actually you need to find the radius OC, which is the radius, okay? If you're given the arc length of AC. So just remember how we measuring the arc length. So this is L, length for the arc AC. How we measure it? We taken the proportion of 2 pi r. Basically, we're taking the fraction of 2 pi r, where r is the radius, okay, of the circle. And which ratio we're taking? We're taking the ratio of what the measure of the arc length is going to be the central angle AOC. So that's why we want to put angle AOC in 360, because the whole, what does it mean? The fraction means the share corresponding to the angle AOC, which subtend the arc minor arc AC. Okay, so right now we are going to find the measure for the angle AOC. Okay, and on the right side we can put 10 pi, because we know that in centimeters that's going to be 10 pi. So actually we are going to use this equation, but we need to find the angle AOC. Okay, so let's try to find in two ways. The first way is pretty obvious, because you're given angle 40 degrees, so both sides in the triangle, so angle AOC from triangle AOC, which is going to be isosceles, because you would clearly see that two sides are actually radius, right? They're radii of this circle. So that means angle here is going to be also 40 degrees. Okay, so that means the rest angle is 180 minus 80, which is 100. So that's why we can easily figure out the angle AOC as the 100, because it's 180 minus double angle of 40, which is 80. Okay, so that works pretty fast, and we can plug in. But I want to show you another way around. It will be maybe relevant to another sort of questions. How you also can get that this angle is 100 degrees. So angle here is 100 degrees that we established. How to figure out? This is the central angle, right? Subtended by the arc AC. But angle ABC, so angle ABC is simply should be twice less than our central angle. Okay, so that's why ABC times 2 is going to be our target angle, AOC. So this is the way 2. So way 1, there's this one, there's this way, and this is way 2. How we can also figure out the angle, central angle AOC. Okay, we established that if we find ABC, which is inscribed, we can find angle AOC as well. But let's have a look at the triangle ACB. So triangle ACB is definitely a right angle. Angle A is 90 degrees. So we can write that angle A is 90 degrees. Why? Because this is inscribed angle subtended by the semicircle length, right? Semicircle because the arc length CB is simply half, because CB is the diameter. So diameter always split your circle into halves. So that's why the measure is going to be half of the half length of the circumference. Okay, so that's why we know any inscribed angle subtended by diameter is going to be 90 degrees. So how we can figure out angle B is simply 40 plus 90 and minus 180. Okay, so it's going to be 40 and 90. Let's set up 40 plus 90, and we subtract from 180. It's going to be 130, and that means the angle ABC that we're looking for, angle ABC, is going to be another 50 degrees. So that's why angle AOC is going to be twice than ABC. But as you can see, way 2 is pretty long, but it might work in some other problems, so make sure you can do that. And also the way 3, I'll also show you why, because that's also might take place. Okay, let's have a look way 3, how to figure out. It's pretty easier. Okay, let's have a look at the angle X. We found on the previous step that angle X is 50. There's a theorem that tells you if you have a tangent line and the angle between tangent line and the chord CA is going to be the same angle as inscribed angle subtended by the same arc AC. So that's why angle B is immediately 50. Okay, so it means that this angle is also X. So that's why angle X is going to be equal to the angle ABC. Okay, and that's why angle AOC is twice than B. Okay, so that's why AOC is simply twice ABC, which is again 100 degrees. Okay, so that's how it works. I consider 3 cases. Maybe it's pretty long, but for now, definitely sure you are sure that you have several ways of calculation. Okay, and right now, okay, we established that the measure of the angle AOC is going to be 100. Okay, so that means we can plug in our equation and finally figure out that 100 over 360 times 2 pi r is going to be 10 pi. So, okay, first what I'm going to do, I'm going to cancel, and I'll leave here 100 and 360 can be cancelled by 10, right? And 10 on the right side will also be cancelled. So that's why you'll get 2 over 36, and pi also be cancelled on both sides, is going to be equal to 1. So that's why r is going to be equal to 1 over, so 2 over 36 is going to be 1 over 18, so that's why radius is going to be 18 centimeters. Okay, so that's the second answer. The first is about angle X, and the second is about the radius. So make sure you have the same answers. Let's go to the problem 2. Okay, so here is the circle. We have the tangent segment AB. Okay, here is the tangent point. And you need to work out the measure for the angle BMC. Okay, so let's set up target angle as X, BMC, it's right there. Oops, more precisely. Okay, so this is angle X. Okay, how to work it out? Probably you was thinking and there is no idea. I'll give you a hint. What if you put perpendicular from the top right to the bottom? So in this case, just let me put more precisely. Okay, so this is the radius, and the radius of the circle always perpendicular to the tangent AB. So that means it will form the angle 90 degrees there. Okay, so my strategy is pretty obvious. Angle COB, let's consider angle COB, is the central angle, right? Because the vertex at the center O, it's twice then our target angle, right? Because target is inscribed subtended by the same arc BC, okay? Or the same chord BC, as you like. That means if this angle is twice x, it's enough to find that angle. But this angle is pretty easy to calculate. It's 31 and 90 minus 31, that's going to be a result, okay? So this angle is simply 59 degrees, okay? So that's why angle COB and angle 59 will give you an open angle. So you can write the equation 2x, which is simply that angle. I just put it for simplicity. So this angle is going to be double x, okay? So if you add double x and your angle 59, you'll get exactly 180 degrees. If you subtract, you'll get 2x equals 121, okay? And now you just divide by 2, which is going to be 60.5 degrees, okay? So that's the degree measure for the angle x, and we easily found it. The problem 2 is actually easy one. All right, so hope you like that. Hope you understand everything there. If not, just go throughout the circles problem. Hopefully I have plenty of them. And don't forget to visit my A-levels videos as well as A-level zillions classes. That was Daniel Dallas, and see you next time.